All right, so let's go ahead and take a look at the optimal solution for 2-sum and kind of how we get to that point. So if we remember from our brute force solution, all we're really doing is checking if num1 plus num2 is equal to our target. And remember, this caused us to loop through the list multiple times. For the most optimal solution, we're going to use the same formula. We're just going to rearrange kind of how we get there. So if we check if target minus num1 equals num2, what we want to do, this num2 is the complement here. So we want to check if this complement exists in the list. So for example, if we have a target of 9 here and num1 is 2, we want to check, does 9 minus 2, which is 7, does 7 exist in this list? Well, it does. So then we want to return the num1 indice as well as that num2 indice because we found two numbers that add to the target. So let's go ahead and implement this here. So if we call a hash map here, we can call it complement map. And what this will be is just a new empty map here, and we can say for I in range. And we want to go all the way to length of nums here. So the reason why we want to do that is because we want to go all the way to the end of the list. We want to check every single number. Then we just want to see, we can call something complement here. And this complement will just make this code a little more readable. But this complement is nothing but the target minus the current num that we are on, the current number that we're on. Then we check if the complement is inside that complement map. Complement. If that target, or I'm sorry, if that complement is inside the complement map, then all we need to do is actually return that. Return those indices. So those indices are going to be accessing the complement map at the complement point, and then also the current index that we're on, which is I at this point. And if it's not inside our complement map, then we want to definitely add it to our complement map. And what this is a key value pair. So the key is going to be the particular number, and the value is going to be the index. So if we go through here, we can actually see, so our complement map is empty at this point. So for I in range of length of nums, our complement is going to be equal to our target minus nums I. So our complement at this particular point is going to be 7. So if 7 is inside the complement map, which it's not at this point, then what we want to do is add the current number, which is 2, and its index to the complement map. Then we go to the next point in this for loop, we increment, and we see that our complement is now target minus 7, which is 2. If 2 is inside the complement map, then we want to return the index where that 2 is, which is 0, and also the index that we're currently on, which is 7. So in this case, you can see that we're able to return this very quickly. And this is the most optimal solution here, and it's actually O of n because we only go through the loop once.